Hello friends, welcome. In this video, we are going to discuss what causes severe air pollution in Delhi during winter. If you're from Delhi or if you're an aspirant staying in Delhi for the last 2 to 3 years, then you must have experienced this severe air pollution in the months of October, November, and even in December. Every year during winter, this problem crops up and then it will be in the news for 2 months, and then January comes and the problem goes and we stop talking about that, right? But the underlying causes still remain, and next year again October comes, the problem reappears. So there are these causes which we must understand to understand what exactly causes this air pollution to spike, especially in the months of winter in Delhi. One important thing that I want to clarify before going ahead is that if you think this problem of air pollution spiking in the months of winter is specific only to Delhi, then that is incorrect. If you look at many important cities across the world, then you will see that winter is a very bad phase. During winter, air pollution spikes, and there are certain climatic factors for this to happen. Delhi is a special case, but in India, if you look at the air pollution charts during the times of winter, then you will see that air pollution spikes in those cities as well. In this video, we are going to study all those causes in detail and understand them properly. So basically, as I told you in the beginning, there are two important sets of causes. One, natural causes, right? Delhi is located at a particular geographical place, and there are some changes in the atmospheric winds which happen during the time of winter, and new type of air patterns in the upper atmosphere generate during winters. All those natural causes are responsible for exacerbating the problem of air pollution in winters. But apart from natural causes, there are some very important economic and cultural factors created by human beings which go hand in hand with these natural causes to increase this problem of air pollution, especially in winter. Because these economic and cultural factors crop up especially during the months of October and November. So before understanding the natural causes for spike in air pollution in winters in Delhi, we need to understand what are the basic layers of atmosphere. If you are a student of geography or if you know basic geography, then you must be aware that atmosphere is classified into different layers, right? If we begin from the ground, then first layer is troposphere, second layer is stratosphere. This layer is very important. Why? Because ozone layer is located in this layer. Then there is mesosphere, thermosphere, and exosphere. So all these layers are very important, but the most important layer out of these layers is troposphere. Why troposphere is the most important layer? This is because all the important atmospheric phenomena that you observe, starting from rain, thunders, lightning, tornadoes, cyclones, anticyclones, frontal cyclones, all these atmospheric phenomena occur in troposphere. Okay, so in this video, when we understand the first cause for spike in air pollution in Delhi, then troposphere becomes very important. And that first cause is temperature inversion. Let us first understand the term. The term is temperature inversion. The term inversion indicates that something normal is getting inverted upside down, right? Something was like this, and then when it becomes like this, it is called as inversion. Now, the term temperature inversion indicates that normal temperature pattern in the troposphere is getting turned upside down, right? So, in order to understand what is temperature inversion, it is important that we understand what is the normal temperature pattern in troposphere. If you understand this one, then it becomes very easy to understand what is temperature inversion, and then it becomes very easy to understand how temperature inversion is the most important cause for spike in air pollution in Delhi. Now let us understand the normal temperature pattern. Normally, if we have not studied geography, the normal understanding is that the atmosphere, right? Atmosphere is made up of what? Atmosphere is made up of gases like nitrogen, oxygen, carbon dioxide, argon, and other trace gases. Apart from these gases, we have certain particulate matters like black carbon, brown carbon, right? And we have dust particles, right? So these are particulate matters which are present in the atmosphere apart from gases. And another most important component of atmosphere is water vapor. These are the components of atmosphere. So normal understanding is that this atmosphere is heated by the sunlight which is coming from the sun, right? Sun emits radiations which are called electromagnetic radiations, and they enter the earth after passing from the ozone layer, right? So we think that these sun rays heat up the atmosphere, and that is how temperature of the earth is maintained. But that is a misunderstanding, right? If you have studied geography, then you know that it is incorrect. Why it is incorrect? Because atmosphere cannot absorb radiations which are coming from the sun. Why atmosphere cannot absorb these radiations which are coming from the sun? Because these radiations are short wave radiations. Okay, the atmospheric components that we just talk about are actually opaque, meaning they allow these radiations to pass unhindered. Hence, they pass from the atmosphere and hit the ground without getting absorbed in the atmosphere. I hope you understood this. Now, then how is this atmosphere heated? How the temperature of the earth is maintained? The normal average temperature of the earth is around 15 to 18 degrees centigrade. How this normal average temperature of the atmosphere is maintained? Now, here is the answer for that. Normally, what happens? Sun rays hit the surface of the earth, and these rays, which are coming from the sun after passing from the ozone layer, are safe and they are short wave radiations. If you have studied electromagnetic spectrum, then you will understand what are short wave radiation. These are the radiations which have high frequency or low wavelength. Fine. Hence, they are called as short wave radiations. They are mostly in the form of visible light, that is from violet to red. Okay. So anything above red are called as long wave radiations. Fine. So these are short wave radiations. They pass through the atmosphere unhindered and they are absorbed by the surface of the earth. Earth acts as a perfect black body. Now, what do I mean by this? For example, if you are wearing a black shirt and if you are walking in bright sun, then you will feel the most heat. Why do you feel the most heat compared to the person who is walking on the road wearing a white shirt? Because black color is an efficient absorber of sunlight or heat. Hence, you feel most heat compared to the person who is wearing white shirt. So, Earth acts as a perfect black body, meaning whatever sunlight falls on Earth, most of it gets absorbed. So, Earth absorbs these shortwave radiations, and this will heat up the Earth, right? Now, once the Earth is heated by absorbing the shortwave radiations from the sun, Earth starts emitting radiations back because after absorbing energy, Earth has to release that energy, right? So, Earth emits back these radiations. So, the radiations which Earth emits back are actually not short wave in form, they are long wave radiations. So these are the sun rays which are coming and hitting the surface of the earth. The surface of the earth absorbs these radiations, and after that it releases radiations in the form of long waves. What do I mean by long waves? Long wave radiations are those radiations which have long wavelength. For example, infrared radiations. So what type of radiations earth emits? Earth emits energy in the form of infrared radiations. Now, what is the beauty of these infrared radiations? Infrared radiations are absorbed by the atmosphere. So, atmosphere is efficient in absorbing long wave radiations. In the previous slide, I told you that when the sun rays are coming from the sun, when these rays are coming from the sun, atmosphere doesn't absorb them, right? Why? Because these radiations are short wave radiations. But when the earth is emitting back these radiations, these are long wave radiations, and atmosphere is very good at absorbing these long wave radiations. So what is the conclusion can we draw from this explanation? One important conclusion that we draw is So atmosphere is heated bottom up, not top to bottom. So this is a misconception. This is the reality. So atmosphere is heated by the long wave radiations emitted by the earth, not from the short wave radiations which are coming from the sun. If you have understood this, then it is easy to understand what is the normal temperature distribution in the first layer of the atmosphere, that is troposphere. So what happens? As I told you, these shortwave radiations from the sun hit the surface of the earth. Let's say this is the surface of the earth. They hit the surface of the earth, and then earth absorbs them and emits back these radiations in the form of long wave radiations, which are absorbed by the atmosphere, right? And that's how atmosphere gets heated. Now let us understand what is conduction. Conduction is a process of transferring heat from one body to another body through direct contact. Now, this is the surface of the earth. It has absorbed the shortwave radiations from the sun and has heated up, right? Now it is warm. It is warm compared to this layer of the air. Okay, on the earth, you have these layers of air, right? Now, this layer of air, which is blowing on the surface of the earth, gets in touch with the surface of the earth, right? And this surface of the earth transfers its warmth to this layer of air. And this process of transfer of heat from the surface of the earth to the top layer of the air, which is touching this surface, is called as conduction. So once this layer of the air or wind which is blowing here gets in touch with the surface of the earth, it warms up because of conduction. And once this layer warms up, it starts to expand. Now, you must have studied this in science that whenever air is heated, it expands if it is not enclosed in a container, right? For example, if it is not in a closed container, then when air is heated, then molecules starts to vibrate and they go away from each other, right? That is how air expands. You got this? So first, air gets heated because of conduction. Once the air is heated because of conduction, it starts to expand. Then once it expands, tell me what happens to the weight. Now, when it is expanding, its volume is increasing, right? The volume of air is increasing. When the volume increases, then it becomes lighter. Got this point? When the air becomes lighter, it starts moving up, right? Whenever something becomes lighter, it means that the gravitational force on that object decreases and that object can easily go up. Take a balloon and just throw it, it will fall to the ground. But blow air into that balloon, it will increase in its volume and leave that balloon, it will fly up. Why? Because now its mass has decreased and its volume has increased. Similarly, that is what happens with air. Whenever air expands, its volume increases, right? Its volume increases and it becomes lighter, it starts going up. This is called as convection. So the first method through which heat transferred in the atmosphere was conduction, and conduction happens through contact, and that is when the surface of the earth gets in touch with wind and then transfer of heat happens. Once the heat is transferred to that layer, it expands and becomes lighter and starts going up. And this way of going up is called as convection, right? As this warm air starts going up, now in the first slide, I told you that atmosphere gets heated up bottom up. That is, atmosphere is heated by the long wave radiations which are emitted from the earth and not from the short wave radiations that are coming from the sun. It means that the layers which are at the bottom have high temperature because they are receiving heat from the earth, and the layers which are above or higher up are less warm because they are away from the source of heat, right? For the atmosphere, the source of heat is earth. So these layers which are near the earth will receive more heat compared to the layers which are away from the earth or surface of the earth. They receive less heat, hence they are less warm. So as this air moves up, right, it loses heat and becomes cooler and cooler as it moves up. And one of the important principles that we just learned, warm air expands, cool air contracts. So cool air contracts, warm air expands. So as this air moves up, it becomes cooler and cooler, and it starts contracting. And when it reaches a particular height, that is tropopause, this has increased in density. That is, it has contracted a lot. When it contracts, what we learned here, whenever air expands, it becomes lighter. Then what happens when it contracts? Obviously, opposite will happen. So the air will become heavier. Once the air will become heavier, it moves this side and starts coming down as heavy objects fall to the ground. Right? You must have heard or read about this, and this is called as Hadley cell. So I'm not going into details about Hadley cell and Ferrel cells. What I'm trying to explain to you here is that whenever air is heated up, it goes up and it cools down because it is going away from the source of heat, right? So that is what normal distribution of temperature in troposphere is. This is the layer of troposphere. For example, let's say this is tropopause. Then what happens here? As you go up, temperature of the air decreases, right? Temperature of this air is highest. As this air starts moving up, temperature keeps on falling. And if you reach the tropopause, the temperature at tropopause is minus 50 degrees to minus 80 degrees centigrade, meaning from 30 to 40 degrees centigrade at the surface, the air drops temperature to almost minus 50 to minus 80-degree temperatures when it reaches the tropopause, right? So this fall in temperature as the air moves up, because it is moving away from the source of heat, is called as normal lapse rate. And this is called as normal distribution of temperature. Now, this normal distribution of temperature is very important for one important reason. That is, whatever pollution we are emitting or whatever pollutants we are generating, because of this normal distribution of temperature, these pollutants are taken higher up the atmosphere, as we just studied, because of convection. Convection, why the convection is happening? Because the lower layers are getting heated up from the Earth's surface and air is becoming lighter and going up, right? And it reaches a particular point, that is tropopause, and this air is pushed towards the side because now it has become heavier because it has become cooler. As it moves sideways, these pollutions which were created at one place are carried to other places because of this wind. This is how pollutants are spread across the world because of this type of temperature distribution. Got it? So normal distribution of temperature is very important for scattering of pollutants from one place to other place. Hence, they do not collect at one particular place. For example, you would never hear of excessive smog formation in Delhi during the months of summer. Why? Because during summer, there is enough sunlight, and that sunlight is warming the earth, and earth is becoming hot, and earth is releasing long wave radiations. These long wave radiations are heating up the lower layers of the atmosphere. Lower layers are expanding, and expanding lower layer will decrease in weight, and it starts moving up. Along with the wind, these pollutants will also move up, and then they become heavier and they go sideways, and these pollutants are taken away from their source. That is the importance of normal distribution of temperature. But when winter sets in, a different situation plays out. Now let us understand what happens during winters. First important thing that you need to know is that there is something called declination of sun. Now let me explain this to you using a simple diagram of the earth. Let's say this is the diagram of the earth. Earth is not exactly round like this. Earth's shape is geoid, which means it is bulged at the equator side and flat at the poles, right? That is the geoid shape, right? So now what happens? Normally sun shines here. During summer, sun reaches till here. Here the Tropic of Cancer is located. Just a rough diagram. Here the equator is located. Here Tropic of Capricorn is located, right? Let's draw India. For example, if I draw India, India is located here, right? For example, India is located here. Here Delhi is located. Fine. It is located just above the Tropic of Cancer. And here you have equator. So India is a subtropical country. right? Tropical as well as subtropical country. And so during summer seasons, for example, June, July, August, during these seasons, sun is shining in the northern hemisphere. This is the sun, and sun actually during the month of, for example, June, sun shines directly overhead the Tropic of Cancer, right? This is Tropic of Cancer. It shines exactly overhead. So it means that these regions in the northern hemisphere, these regions will receive maximum sunlight during the months of summer. Fine. These regions, these all the regions in the southern hemisphere will receive minimum sunlight during summer months in the northern hemisphere. जब नॉर्दर्न हेमिस्फेयर में समर होता है तो these southern hemisphere regions will receive minimum sunlight and minimum heat. But what happens during the months of September, October, November, December? During these months, sun actually moves southwards. Sun doesn't move, the earth revolves. It appears that sun has moved to the southern hemisphere, right? Let's go to the month of October and November. During these months, sun is somewhere around here, right? Now, tell me, where do you have maximum insolation or maximum sunlight or maximum heat? Now, the maximum heat will be in the southern hemisphere because this is where sun rays are shortest and sun rays are direct. What happens in northern hemisphere? Northern hemisphere, sun rays are coming from the horizon and they are traveling a lot of distance. Hence, they have less energy and less heat, meaning northern hemisphere during the months of September, October, November, December will receive minimum heat and minimum sunlight. Understood? This is very important to understand what is temperature inversion. Now, so because of this reason, what happens is that the amount of sunlight which is reaching northern hemisphere, India, Delhi during the months of October and November is less, right? Less compared to June, July, and August. So total heat received during winter is less. That is why there are winters in the northern hemisphere and in Delhi, for example, right? October, November mein temperature drops. For example, in June, July, Delhi temperature is 40, 45 degrees centigrade. But in the months of October, November, the temperature is around 20. In December, it is around 10 degrees centigrade, right? So this is why. Why? Because the sun has declinated to the southern hemisphere. Fine. During the daytime, what is happening is this is the surface of the earth. During the daytime, the amount of heat which is coming to the surface of the earth is actually very low, meaning the earth is not getting as warmed up as it happens during summers, meaning the temperature of earth is just 15 degrees to 20 degrees, right? So total heat received by the earth is low. So the total heat emitted by the earth will also be low, right? Let's talk hour by hour situation. For example, let's talk about what happens during 4 p.m. You must know that during winters in northern hemisphere, daylight is less. For example, sunset happens usually at 5:30 to 6 p.m. But in summer, sunset happens at 7:30 p.m. as well. So, total daylight is less. So, by 4 p.m., Earth has emitted back, let's say, 60% of the energy or heat it received from the sun. But as the time passes, let's say now we are talking about 8 p.m. By 8 p.m., there is perceptible drop in temperature of the Earth's surface, right? For example, if you're in Delhi, then you must know as we near the night, the overall temperature in the region falls, right? So that is what happens. So at 8 p.m., temperature will drop even further. But as we go to, let's say, 11 p.m., the temperature drops even more. Now, Earth has emitted back 75% of radiations that it received from the sun during the daytime. Now, what percentage of heat is remaining with the Earth's surface? 25%. Right? Now, let's go to 3 a.m. in the morning. Now, Earth has emitted back 95% of the heat that it received from the sun. Now only 5% is remaining, meaning the surface of Earth is becoming cooler and cooler, right? Because it is emitting back the energy that it has received during the daytime, which is actually less because during winters, the total sunlight received is less, as I just told you, right? Now let's go to 6 a.m. What happens at 6 a.m.? At 6 a.m., Earth has emitted back almost 100% of the energy that it had received from the sun during the daytime. Now Because of this continuous emission of long wave radiations for whole night, the earth has become very cool. Maybe the temperature of the surface of the earth has dropped to, let's say, 10 degrees centigrade during the month of October or first week of November, right? Now this is 10 degrees centigrade. At 6 a.m., the surface temperature of the earth is 10 degrees centigrade. Example, right? Now let us understand what happens after that. So, if the temperature of the surface of the earth drops to 10 degrees centigrade, now what happens after this? The air which is coming in touch with this surface will also become 10 degrees centigrade warm, right? Meaning this is very cool. In fact, I should not use the term warm at all here, right? So, this wind which is in touch with the surface of the earth will also acquire the temperature of 10 degrees centigrade, right? But the wind which was above will not be 10 degrees centigrade. Why? Because see, the surface of the earth is losing temperature faster. So it will transfer the same temperature to the air which is in touch with this surface. But the above layers at night haven't been in touch with this surface layer. This layer is located higher above. Hence, this has not come in contact with this layer which has become very cold, right? It has reached to 10 degrees centigrade. Hence this layer has temperature which is more than the temperature of the layer which is in touch with this surface of the earth. Getting my point? So the surface of the earth is 10 degrees centigrade. The layer of the air which is in touch with this surface will also be 10 degrees centigrade because it will acquire its temperature from the surface of the earth. But the layer which is higher above will not be 10 degrees centigrade, but maybe it is 15 degrees centigrade. Why? Because this is not in touch with this cold layer of surface of the earth. Got it? This will retain the temperature that it acquired during the daytime when the temperature of the overall temperature of the atmosphere was 15 degrees centigrade, because earth also had 15 degrees centigrade at that time, let's say 3 p.m. in the evening, right? In the afternoon. But as this layer was on top, not in touch with the surface of the earth, it remained at 15 degrees centigrade, but the layer which was in touch with the surface of the earth becomes 10 degrees centigrade. Now, this is a very typical situation. The layer above is at 15 degrees centigrade, the layer in touch with the surface of the earth is at 10 degrees centigrade. Now, tell me what happens. This layer is lighter, right? Because it is warmer. Warm air expands and becomes lighter, as we just studied. So this layer is lighter compared to 10 degrees centigrade wala layer, because 10 degrees centigrade is cooler compared to 15 degrees centigrade. So this layer will be heavier compared to this layer. So tell me whether this layer will go up or not. Obviously, heavier layer will settle down rather than going up, right? So heavier layer will be at the bottom rather than going up. Lighter layer will remain at the top because it is lighter compared to this layer. Now, normally in troposphere, what happens? As you go up, temperature decreases, right? And this is very important for dispersion of pollutants, because as you go up, temperature decreases, and air which is going up will take the pollutants along with it and disperses it to other places. But now what is happening because of winter and long nights of winter and less sunlight? As you go up now, see here the temperature is 10 degrees centigrade, here the temperature is 15 degrees centigrade. Now reverse is happening. As you go up, rather than temperature falling, which is normally the case in troposphere, temperature is increasing from 10 to 15, right? So this is called as inversion of temperature. That is, normal temperature distribution in the troposphere gets inverted. Rather than temperature decreasing, temperature will increase. So this is called as inversion of temperature. This is what happens during winters. Now, because of this, there is an important complication which arises. Now, because of inversion of temperature, what happens? Normally, as we have discussed, there is a dispersion of pollutants in summer because the convection happens, right? But in inversion of temperature, convection will not happen. Why? Because At the bottom, we have denser and heavier layer. At the top, we have lighter layer. Why would heavier layer go up? It will settle down. And along with it, it will also keep pollutants at the bottom only, because there is no convection now. So, because of temperature inversion, convection stops, and this traps the pollutants within the lower layers of the atmosphere. So rather than pollutants getting dispersed because of convection, there is no convection during winters, and pollutants are trapped within the lower layers of the atmosphere. And this is exactly what happens in Delhi during winters. So this is the most important and first important cause for pollution spiking up in Delhi during the early months of winter. So if you have understood inversion of temperature and its impact on pollution in Delhi during winters, then the next two important reasons, which are natural and climatic reasons, are wind direction and speed of the wind. So let us understand how wind direction is an important cause for rise in pollution during winters in Delhi. So normally, if you study geography, then you will know that normally wind blows from which direction to which direction? Normally, wind blows from area of high pressure to the area of low pressure, right? This is the normal direction of movement of wind. Wind basically tries to fill the low pressure, right? For example, I will explain to you using a map of India. Let's say this is the situation in the months of summer, and here is equator. Now, if you have studied monsoon, then you must know that during during summer months, winds blow from southern hemisphere and they become southwesterly monsoon winds, right? They come from here, they cross the equator and they become southwesterly monsoon winds, right? So this is the normal wind movement during summer. Why it is happening? Because these areas which are in the southern hemisphere during summer months of northern hemisphere have high pressure, and here in the northern India, right, here because of intense sunlight, these areas will have low pressure. During summer, high pressure will be in the southern hemisphere, low pressure will be in the northern hemisphere, right? And winds will try to fill the low pressure by moving across the equator. So this is the normal movement of wind during the summer months. That is, they are southwesterly, meaning they are coming from the southwest direction, right? But in winters, this direction of wind changes, and that becomes one of the reasons for spike in pollution of Delhi. So normally in winters, as I just discussed, what happens to sun? Sun will declinate to the southern hemisphere. Okay. Now, because of that, the wind direction over the Indian subcontinent completely changes. For example, if we look at the winds in Bengal side or Bay of Bengal, they will be blowing in the northeasterly direction. And if you look at the winds in Ganga Valley, they will be blowing in no- north to south direction. And most importantly, if you look at the winds in the northwestern side of India, they will be blowing from northwesterly direction. Now, this direction of wind flow is very important, right? Now, why this is very important? They are blowing from northwesterly direction, right? And here we have Delhi. Now, let us understand this situation in the next slide. So, here we have Delhi, right? And in winters, that is October and November, winds will blow from northwesterly direction, right? And one of the reasons most cited in newspapers for spike in air pollution is stubble burning, right? This is the most important reason cited, which to an extent is correct. But apart from that, there are many other factors also which to cause the spike in pollution in Delhi during winters, right? So what happens because of these winds? These winds will blow from Punjab, Haryana, and northwestern UP towards Delhi during the early months of winter. These winds, which are blowing from these states, will bring the smoke created by stubble burning from these states to Delhi, and this is Delhi. So, this geographical factor of Delhi being at this fateful place plays out here, right? These winds, which are normally blowing from northwesterly direction during winter, bring all that smoke towards Delhi. And at Delhi, we have already seen that there is a temperature inversion, which is preventing these pollutions from getting dispersed to other places because of lack of convection, right? So this is the second most important factor, that is wind direction. Another important factor is there connected to this, that is jet stream. What is jet stream? What are they? How are they formed? That is another topic we will discuss in some other class. But understand one important thing. Normally during summer, there is this jet stream, that is subtropical westerly jet stream, normally blows northern side of the Himalayas. If these are Himalayas, this jet stream during summer blows north of Himalayas. But as the sun moves south, this jet stream also moves south, and during the times of winter, this jet stream blows just south of the Himalayas, right? This also brings out the pollutants which were created because of stubble burning in Punjab, Haryana, and Western UP towards Delhi. So, this is another factor for spike in pollution. So, now that we have covered wind direction, let us understand what happens to wind speeds. So normally what happens in the months of summer, here we have high pressure and here we have low pressure. So, and this low pressure is very intense because of one factor called continentality. Now, what is continentality? Please Google, or I may try to explain this in the future classes. So, because of continentality, the low pressure generated here is very intense, and this acts as a suction machine which pulls up the winds from southern hemisphere towards itself. And because of this, the winds over Indian subcontinent during the time of summer are extremely heavy and powerful, right? Why? Because of this excessive low pressure zone which is created in northwestern India. This acts as a suction machine which pulls up air from all across around. Hence, these winds come to fill this low pressure, and along the way they carry moisture, and that is what southwest monsoon is, right? But what happens during winter? Now, during winter, high pressure is created here and low pressure is created here, but this low pressure is not very strong. And because of this, the wind speeds during winter are slow, right? The winds normally blow at 5 to 8 kilometers per hour. So this is the situation during winters in northern hemisphere, that is Indian subcontinent, right? The time when we need the wind speeds to be very high because we don't want this pollution to stay at one place. We want this pollution to be dispersed, but actually the wind speeds decline. Why? Because of lack of suction from this low pressure, because this low pressure is not very strong because of lack of continentality. Hence the wind speed over northwestern India is slow, and this prevents the dispersion of these pollutants. So this becomes the third most important factor for spike in pollution in Delhi during winters. Another important factor for Delhi that it is located at the southern part of Himalayas. Now, what is the problem of that is these Himalayas act as a strong barrier for the winds to blow from southern side to the northern side. So these Himalayas block the movement of wind, which makes the pollutants get stuck in Delhi, right? These act as natural blockers or natural barriers. So all these factors create a landlocked condition over Delhi. So these northwesterly winds which are blowing are bringing stubble smoke from Haryana, Punjab, and Western UP. And here we have Himalayas which are preventing the flow of these pollutants towards the north, right? And here we have winds which are blowing in north easterly direction. They are also bringing pollutants to this area. So from all the sides, Delhi is getting pollutants, but there is no place for Delhi to remove these pollutants, and the natural way to remove through convection and divergence is also absent because of temperature inversion. And because of these reasons, pollution spikes up in October and November in Delhi, right? Hence, this landlocked condition is created in Delhi during the early months of October and early months of winter, that is October and November, creating spike in pollution. Now, after understanding the natural causes or climatic factors for pollution spiking in Delhi in winters, let us understand a few important anthropogenic causes, meaning these are the causes which actually add to the climatic factors. They exacerbate the climatic factors and worsen them, right? We have already covered stubble burning. What is stubble burning? Basically, the kharif crops, the leftover portions of kharif crops are burnt by farmers because of two reasons. One, they do not have machinery to clear the ground. Second, there is also a factor that this burning will enrich the soil and increase the overall nutrient quality of the soil, right? But the problem is when this stubble is burnt, the smoke and soot and all the particulate matter which is created in these states will be carried towards Delhi through the northwesterly wind and jet stream as we just studied. So that is the effect of stubble burning. So next is particulate matter. Particulate matter is basically solid particles of different sizes which are present in the atmosphere. Now, let me tell you one important thing. It doesn't mean that these particulate matter and other solid particles which are present in the atmosphere are suddenly increasing in winter. No, it's not like that. These are present normally in the atmosphere of Delhi even during the months of summer, but we can't see the pollution. Why? Because there is a natural process of convection and dispersion of particulate matters which is active. But because of temperature inversion, all these particulate matters which are created because through different processes get stuck in Delhi. They can't go away because of temperature inversion. Hence, they combine with the water vapor which is present in the atmosphere to create smog. Right now, what are the different ways through which particulate matter is created? Particulate matter can be created because of mining activities which is present around Delhi, or construction activities which is continuously going on in Delhi. This is another reason for presence of lot of dust particles and particulate matter in Delhi. Another most important factor is vehicular pollution. This pollution also releases lot of important particulate matters, and especially one important thing which acts as an important agent in the formation of smog is oxides of sulfur. So these oxides of sulfur act as very important constituent of the Delhi smog which happens in October and November. Another factor which is talked about in news is firecrackers. During these months, cultural factors like religious festivals and all also happen to be at the same time. So these also add particulate matter to the existing atmosphere, and they also lead to increase in the overall pollution level of the Delhi during winter only. So all these are anthropogenic causes, right? These anthropogenic causes increase the climatic factors, meaning they exacerbate the climatic factors and create smog like situation, and pollution level will spike, right? And these two factors, that is natural and anthropogenic factors, together combined to create the situation which is now we are facing in Delhi. That is smog situation which is not at all good for adults, children, pregnant women, old people, patients of asthma, COPD, and other lung and heart disease patients. This is a very killer smog which will have severe health impacts. In fact, according to one report, the lifespan of people who are in this atmosphere decreases by 10%, right? And according to recent report by World Health Organization and other organizations, millions of people die every year because of smog worldwide, right? And in Delhi, thousands of people suffer from many lung problems during these smog like conditions, right? Now, basically, we have understood the whole topic, all the reasons, natural as well as anthropogenic. Now, let me classify two different types of smogs that we normally see. The first type of smog is London type smog. The smog which is present in Delhi right now, smog basically means smoke plus fog. Fog is a normal condition which happens because of presence of water vapor in the atmosphere. But when that fog combines with particulate matter and smoke and dust particles and other such pollutants, it creates a killer smog, right? It is called as London type smog because this was first observed at a considerable level in London during 1957, and around 12,000 people were killed because of this smog during that time in London. Hence, it is named as London type smog, and this type of smog usually happens in winter months, right? And it is observed not only in Delhi but other cities of the world as well. please Google and find out which other cities suffer from this type of smog that Delhi suffers from, right? And it happens in winter. Another type of smog is called as Los Angeles type of smog. You know this by another name called photochemical smog. And this type of smog happens in summer months. Obviously, you might ask, I don't see any smog during summer months. Yes, this smog is not visible, but it is very, very dangerous because it contains substances which can have life-threatening impacts, right? So these are the two most important type of smogs. One is London type, second is Los Angeles type. So this is all about today's topic. I hope you have understood. If you have not understood, then please go back to the and understand once again. And if you have liked the video and if you think that this video can help others as well, then please share, subscribe, and share with as many people as you want. Thank you for watching the video. See you next time.